Now let us move on to simulating the characteristics of the devices using our PSpice schematic software. Okay, so first of all, let us look at the PSpice Capture CIS or schematic software in a bit first before we start simulating. Okay, so when you open PSpice schematics or when you open Capture CIS, so this is the window that we will look at. First of all, we have to create a new project. So we go to File, New, Project. Okay. Select analog or mixed A/D. Okay, so this is the type of project that we want. And give your project a name, say lab 1. Okay, say lab 1. Select the location where you want to save that. Okay. Uh, you will need that if you want to open the file again. And then press OK. You will be presented with this window which says whether you want to create based on an existing project or whether you want to create a blank project. We're going to create a blank project. Okay. So select that, then press OK. And this is the window that you obtain. Okay, so this is the board where we place our components in and connect them in order for us to simulate them. Now, so we have some options at the right hand side of our window. Okay, so the first one is just the select. So this is the one where you can select various type of devices. Okay. The next one is place parts. Okay, so this is the option that we will use to place different type of parts in our board or in our schematic. Okay, so before we can use place parts, one important thing to know is we have to add the libraries. So make sure you do this before you start simulating any project. Okay, so press add library, go to your PSpice installation folder. Okay, so and then you will find a folder called library. So in your PSpice installation folder, you will find a folder called library. Go into that. There is a folder called PSpice. Double click on that. Select all the elements in this folder and then press open. Okay, so make sure you do this before you start simulating any of today's experiments because you will need those devices in order for us to build the circuits. Okay, so this is a very important step. Underneath the place parts option, we have an option called place wire, which we can use to draw wires between different parts. Okay, and the other option that we need for today is down here called the place ground. Okay, so it says GND. So if you click on that, you will be presented with the ground that we use. So this is the ground that we will use today, 0/source. So these are all the buttons from the right hand side that you're going to need for today's lab. And these are, the most important buttons. So you have your place part, you have your place wire, and you have your place ground. Okay. So let us look at what type of circuit you have to build. Go to your lab sheet and look at the circuit. So this is a circuit that we're going to be building to observe the characteristics of an SCR. We have a sinusoidal voltage source to supply input voltage. Okay. We have two resistors. We have a DC voltage source, and we have a DC voltage source, and we have our SCR. Now the DC voltage source is there to supply our gate current. Okay, so the DC voltage source is connected to the gate terminal through a resistor. So we need a DC source for our SCR because we have to supply positive gate current. That is a requirement of the SCR. So that is why we're using a DC voltage source. And we also have our ground. So let us build the circuit first. So we need, first of all, let's click on place parts. Okay, and you will get this window. The first thing we need is our sinusoidal voltage source. So to find that, we write V sin, VSIN. Then select the option that says VSIN/source. Okay, there could be multiple sine wave sources, but we want the one that says VSIN/source. So press OK, and you will get the device as a draggable icon. And if you click anywhere on the board, you can place your circuit, place your component. Okay, so That should be very simple to do. Next, we need our two resistors. So again, we go to place parts and we write R. We select R/analog. Okay, so this is the type of resistor that we're going to use, R/analog. Press OK, drag it to where you want on the circuit, click, and you can place it. So we need two, let's place two. Okay, we need a DC voltage source, so we go back to place parts, and for DC we write VDC, and then again we select the one that says VDC/source, so we have to select that one. Okay, so press OK and place your DC voltage source where you want in the circuit. So to get out of this sort of selecting the object, you press escape. Okay, so then you can have your mouse cursor back. And we also need our SCR, right? So the SCR, we have to look at the name. So in this case, we're using 2N1595. This is the name of the device. So when you go to place parts, so when you click on place parts, you have to write 2N1595. Okay. Again, there could be multiple 2N1595s. Okay, so you have to select the one that says 2N1595/thyristor. Okay, make sure you select this one, otherwise your characteristics might differ. Okay. Now, for the SCR, we have to rotate it, right, to place it in our circuit, because we want the gate to be, facing the resistor, right? So to do that, while you have the device selected, right click and press rotate. Again, we have to rotate it again, so right click, press rotate, right click, press rotate, and now the gate terminal is aligned with our resistor. So then we can place it. Okay. And then press escape to get out. And this is mostly all of our elements. We just need our ground, right? So to do that, we go to the ground, place ground option, click that, select 0/source, press OK, and then put that in our circuit. So that is all the components we need to simulate the characteristics of our SCR, right? And now we have to connect the wires between all the terminals of the components. So to connect the wires, we have to use the place wire option. So that is below the place parts. So below place parts, you will find a toolbox called place wire. Click on that and you will be given a wire drawing tool. Okay, so the way to use this is you go to the terminal of the device where you want to draw a wire from, click and you hold, click and hold from that, and then you will see a wire coming out. Okay, so, and then while you're clicking and holding, go to the terminal of the device that you want to connect it to. So say this terminal, and then release your mouse. So the important thing is you have to click and hold. So go to the terminal, click, hold, and then drag to the terminal that you want to connect to. Okay. So in this way, connect all the terminals according to our circuit. Okay. So this is how you should connect it. And we have to connect our ground. Okay. Next, we have to assign the values. Okay, so we have to assign each value to all the elements. So for our sinusoidal source, we're going to use an amplitude of 12 volts and a frequency of 50 Hertz. V off refers to V offset. This is the DC offset. Okay, so this is what will move our curve upwards or downwards. So we're going to use V offset equal to 0, amplitude of 12 volts, and a frequency of 50 Hertz. So to change these values, what you do is, first of all, to set V offset, you double click on the V offset. Okay, so double click on the V offset, put in 0, and then press OK. To set the V amplitude, double click on the V amplitude, set the value, which is 12 volts, and then press OK. And for the frequency, double click on the frequency, place the value, which is 50 Hertz, and then press OK. Right, so that's how you assign values. Similarly, for the resistors, we have a 500 ohm resistor here and a 2 kilo ohm resistor here. So to set the values, what you do is you double click on the value of the resistor, so not on R1, okay? Double click on the value of the resistor and then put in the value that you want. So in this one it has to be 500 and this one has to be 2 kilo ohms. So to put in 2 kilo ohms, you can just write 2K and then PSpice will automatically set that to 2 kilo ohms. And lastly, we have to set the value of a DC voltage source to 5 volts. Okay, so double click on the value, not on the name or on the device. Double click on the value and then set that to 5 volts. Okay, so that's all our devices adjusted. So this is our completed circuit. Okay, now we have to simulate this circuit. So before we do that, we have to select what type of simulation we want to perform. So the next step is to go to this tab called PSpice. Okay, at the top, next to File, Edit, View, you will find an option called PSpice. So click on that and select New Simulation Profile. Give your simulation profile a name. So say Lab 1. Okay, then press Create. And this is the window that you will get. We want to conduct a time domain or transient analysis. Okay, we have a few options here, but we want to conduct a time domain analysis. We want our variables to vary with time. Okay, and we have two things we can set here. We can set the run to time, and we can set the maximum step size. So the run to time is the total time that our circuit will be simulated for. So for this circuit, let's say we can use a value of 100 milliseconds. Okay, so that's the total time our simulation will run for. And the maximum step size is the step size or the step size of the curve. So the length of each step in our simulation. So the smaller our step size is, the more smooth our curve will be, right? So let us set the step size to 50 microseconds. Okay, to put microseconds, we put U. So okay, so just write down M, then press OK. So that will set our simulation settings. And then to simulate this circuit, all we have to do is go back to the PSpice tab and then select Run. Okay, you can also press F11 or you can select Run. One thing I forgot to mention is before running the circuit. So PSpice actually lets you analyze the voltage at any point. Okay, so it can allow you to analyze the voltage at the anode terminal of your SCR, for example. But we also need the current, right? We want to observe the IV characteristics. So we want to also get a measure of the current in the circuit. To do that, we have to use a current probe. Okay. So to find the current probe, you go to the portion here. So you see it's 4 types of, these are all probes. Okay, so we have a voltage probe, you have a voltage differential probe, you have a current probe, and you have a power probe. So we're going to select the current probe, and with the current probe, we have to place it at the terminal of one of the devices. Okay, so as we want to get a measure of the current in the circuit, right? The current flowing in the circuit, not the gate current. So we will have to place it in this portion of the circuit. So let us place it at the terminal of our resistor. Okay, so as I said, with the current marker, you cannot place it anywhere on the circuit. You have to place it at the terminal of a device. So if I try to place the current terminal at a wire, it will just give me an error that says the current marker will be ignored unless connected to a pin. It will only let you connect to a specific terminal. So like this terminal, I can connect it to. Okay. So we can only use one. We don't need multiple current probes. So let us use one current probe. And now our circuit is completed. So we can go to PSpice and we can go to Run. So on the y-axis, you can see that we have current, right? So this is what we want on the y-axis. But on the x-axis, it is giving us the time. To simulate the characteristics on the x-axis, what do we want? We want the voltage, right? We want the voltage but we also want the voltage across the anode of our SCR. Okay, so we have to change the x-axis variable to the voltage across the anode of our SCR. To do that, we go to the top here, next to File, Edit, View, and we select the option called Plot. Okay, so select that, and then go to Axis Settings. Go to the X-axis tab. Okay, so we want to change the X-axis, right? So we have to go to the X-axis tab and select the axis variable. So we want to change the axis variable. So press the axis variable button. Now you can see before all the options we have I, right? So that means these are current. So R1 is current through R1. X1 A is the current through. Okay, so one thing to note is X1 is what our SCR is called. Okay, so X1A means current through the anode of our SCR. We need the voltage through the anode of our SCR. So scroll down until you see voltage. Okay, so these are the voltages. See, they are denoted by V. We have to select the voltage that shows the voltage across the anode of our X1 device. Okay, so this is the one we want, V X1 semicolon A. So select that and then press OK. And let us define a range. So let's say we want our range in the x-axis to be from -2 volts to +2 volts. Okay, so -2 volts to +2 volts. And we want our scale to be linear. Don't change anything else, just change the range to -2 volts to +2 volts. Okay, then press OK. And now you will see that we're getting the characteristic curve of our SCR. Right, so this is the curve that we observed in our theory. So if we go back to our theory, we will see that this is the curve that we want to get, right? This is the characteristics of our SCR. And you will see that this is the curve that we have obtained. So in the forward direction, we have the forward breakover voltage. So this is the maximum of voltage that the SCR can block before it transitions to the on state. From 0 volt to the forward breakover voltage, we have the forward blocking mode, right? And then we have, after the forward breakover voltage, we have the transition to the on state. And we also have our holding current at this, around this point, right? So if we look at our curve again, this is the point where we have our holding current. So it should be around this point. So we have simulated the characteristics of our SCR, right? We have our current in the y-axis, we have our voltage in the x-axis. If we want to measure the holding current, right? So what we have to do is we go to this option here at the top where it says toggle cursor. Okay, click on that. Click on the point that we want. So this is the point that we think the holding current is at. So select that point. Okay, and then it will show you that value, right? So probe cursor is equal to 511.211, 11.395. So we want the y-axis variable, which is 11.395 milliampere, right? So it's 11.395 milliampere. We can also view, show the values at this point by clicking this option, which says mark label. So if we select that, it will label that point that we selected on the curve. And as you can see, the voltage value is 511.211 millivolts, and the current value is 11.395 milliampere. So the value of our current, or our holding current in this case, is 11.395 milliampere, and you can make a note of that. So that concludes the characteristics of our SCR using PSpice. Next, we're going to simulate the characteristics of our triac. Okay, so this is the circuit that we're going to use to simulate the characteristics of our triac. Similar to the previous circuit, we have a voltage, we have a sinusoidal voltage source, we have two resistors, we have our triac itself, and we have a ground. Okay, so one thing to note here is that we're not using a DC voltage source to supply current to our gate, right? We can use the same voltage source. We can use one voltage source to supply, for the gate as well as for the circuit. Okay, so this is because, as I said before, for the triac, we don't need positive gate current, right? The gate current can be either positive or negative. So a sinusoidal voltage source will be okay, or we can use a sinusoidal voltage source to supply our gate current to our triac. So that is why we don't have a DC voltage source in this case. Now, so again, we have to build the circuit, right? So we need our sinusoidal source, we need two resistors, we need our triac, and we need our ground. So let's go to our place parts. Let's again bring out our V sign. Again, select the one that says V sign / source. That's okay. Drag it to where you want, place it. We need our two resistors, so let's go to place part. Type R, select R/analog, press OK. Place the two resistors that we need. And then lastly, we need our triac. So our triac is called 2N5445. So go to place parts, write 2N5445. Okay, and then again, select the one that says 2N5445 / thyristor. Okay, so this is the one we need. Press OK. Again, we need to rotate this, right? So let us rotate this so our gate aligns with this resistor here. So right click and rotate until you get this. Place it. And we also need our ground. So go to the ground option. So place ground. Press that. Select 0/source. Click on that and press OK. And then place it in our circuit. Now let's connect the wires. So we need to go to place wires. Again, we need to go to place wires. Click on that. Select your place wire tool. Start at one terminal. Click and hold and drag to the next terminal and then release. So you should be able to do this by now. It's pretty simple. And then this is connected to our voltage source. And we can connect this here. And we need our ground. Okay. Let's assign the values. So again, our V offset is 0, V amplitude is 20, frequency is 50. So V offset is 0. This is a DC offset again. V amplitude, so double click on that, put 20 volts. And the frequency will be 50 Hertz. So double click on that, write 50, press OK. So that's our voltage source assigned. Our resistor, one is 10K, the other one is 100 ohms. So double click on the resistor value. This one should be 10K. And this one should be 100 ohms. So 100, that's okay. And that is all our variables assigned. Again, we need a current probe, right? So we want to measure the current on the circuit. This is what will show up on the y-axis of a curve. So again, we select current probe or current marker and place that on the terminal of this resistor. Again, remember, you can only place this on a terminal. You cannot place this on the wire itself. Okay, so make sure you place it on the terminal of your resistor. So that's our completed circuit. If you open a new file, so you can go to PSpice and the new simulation profile again. But I'm using the same file as before, so I can just go to PSpice and select Edit Simulation Profile. Again, we're going to count up time domain analysis, so we won't change that. We'll keep the same run to time, which is 100 milliseconds, and the same maximum step size of 50 microseconds. Okay, so just make sure these are the values that you have assigned. Press OK, and then go to PSpice and run simulation. Okay, so again, we have our current in the y-axis, but as with before, we have our time on the x-axis. So we have to change the x-axis variable. So with that, it shows our voltage across our device, which is our triac. Now recall that instead of anode and cathode for a triac, we say that is MT2 and MT1. So we want to observe the voltage across the MT2 terminal of our triac, which is X2, right? So we have to change this to phi X2 semicolon MT2, right? So as with before, go to plot, go to axis settings, click on x-axis, make sure you're on x-axis, click on axis variable, and we're going to change that to voltage. So we have to find the V markers. So let's go to down and see. We have to select the one that says V, X2, that's our device, and MT2 is the terminal that we want the voltage across. So we want the voltage across the MT2 terminal of our device X2. So that's why we select this one. Press OK. Again, we can change the range. Let's say we want this time, because it's a triac, we want to put minus 10 volts to plus 10 volts. Okay, because we need a bigger range of our voltage. And then press OK. So this is the characteristics of a triac, right? If you recall from the theory, then this is the characteristics that we want, right? We want our forward breaker voltage, then we want the device to turn on, and the same thing in the reverse direction, right? So this is exactly the same characteristics that we obtained in our simulation. So this is the forward breaker voltage, this is the reverse breaker voltage, this is the forward holding or latching current, and this is the reverse holding or latching current, right? And again, we can find the value of this holding current by simply going to this option of toggle cursor, right? Toggle cursor, select this point, make sure you select that point exactly, right? So select this point, and then you can look at it here. So it's 2.1617 microampere, or we can place the marker. So mark label. So this is the label that we want marked, and you can see it's 817.179 microampere, right? Sorry, that before showing that point, we have to set this point. And again, we can place the marker at this point, right? So this point, and that will give us what? Minus 810.15 microampere. So this should be the same value. So they should both be around 800 microamperes. Okay, and that means that you have simulated your circuit properly. So that is the characteristics of our triac. And lastly, we want to simulate the characteristics of our diode. Okay, so to simulate the characteristics of our diode, instead of using the time domain or transient analysis, we're going to be using something called DC sweep. Okay, so what DC sweep does is it varies the DC voltage source to find the characteristics of the device at different values of voltage. Okay, so first of all, let's construct our circuit. So for the diode, we don't need a sinusoidal source to look at the characteristics. We're going to use a DC voltage source, right? So go to place parts, and then write VDC, select VDC/source, press OK, and then put that in your circuit. That's your source. We need one resistor, so click on place parts, write R, and select R/analog, press OK, put that in your circuit, and we need our diode. So the diode model that we're going to use is D1N4001. Okay, so you can find that in your lab sheet. So again, go to place parts. In the part option, write D1N4001, and then select D1N4001/diode. Okay, so this is the one that we're going to use. Press OK. We will need to rotate this a bit to make it align with our circuit. So now it's aligned. Place that. And we also need a ground, right? Of course, we need a ground. So press place ground. Select 0/source. Press OK. And then place our ground. Now let's connect the wires. So go to place wire. Select that. And then connect all the terminals as before. So that's connected. Let's assign a value of our DC source for, let's say, 10 volts. And let's keep our resistor at 1 kilo ohms. And we also need, we need a current marker to measure the current in the circuit, because we want our y-axis to be the current, right? So let's place it again on the terminal of our resistor, not on the wire, the terminal of our resistor. Press escape. And that's our circuit build. Now, we need to edit the simulation profile, right? This time we don't want time domain or transient analysis. We want to perform DC sweep. So what DC sweep will do is it will vary the value of this voltage source from, say, we can set it to vary from 0 to 10 volts, right? It will vary from 0 to 10 volts, and it will give us the characteristics of the device from 0 to 10 volts, right? So because we're using a DC source, we can use the DC sweep option. If we use AC source, then we can use the time domain option because the AC voltage varies with time, but the DC voltage does not vary with time, right? So that's why we need to use the DC sweep so that we can vary the value of the voltage source from between certain values to plot the characteristics of our device. Okay, so that's why we're going to be using DC sweep. So you go to PSpice, you select again new simulation profile, give that a name, say diode, press create. Okay, so then in analysis type, drop down and select DC sweep. Okay, and select primary sweep. So you have to select primary sweep. Now, the sweep variable, so our sweep variable is going to be our voltage source, right? So this is the voltage source is what we're going to vary from between certain values. So the sweep variable is going to be voltage source, and in this box we have to write the name of our voltage source. So in this circuit, the name of our voltage source is V4. Okay, so we have to write V4 here. One thing to note is that in your lab sheet it says V1. Okay, so don't just write V1. Check the name of your voltage source. So in our lab sheet, the name of the voltage source is V1. That's why they put V1 here. But in this circuit, for example, right, we are using the name of our voltage source is V4. So right, so that's why we're putting V4. Okay. So that is very important. Make sure you get the name of the voltage source correctly. And we want to perform a linear sweep, so make sure that is selected. We can set the start value. So let's say we want to start at 0 volts. Okay. And let's say we can end at 10 volts. So because our voltage source is 10 volt DC, we can end at 10 volts. And we can put increments of, let's say, 0.1, right? We can put increments of 0.1. So this is the increments between each step, right? So that is our DC sweep settings. Let's press OK. So where did our current probe go? We have to place another current probe here. Okay, make sure that is there. Then go to PSpice and select run. Okay, and so for DC sweep, we don't need to change the axis variable because it's going to be the voltage, right? So on this axis we have our current, but on this axis we have the voltage. We have basically our source voltage. So our source voltage is varying from 0 to 10 volts. So we have to change that to the voltage across our diode, right? So in this case we have to go to plot, and then we select our axis settings. We select our axis variable. We want the voltage across terminal 1 of our diode, I believe. Alright, okay, let's check if it's terminal 1. And let's say the range is between, okay, let's just keep the same range. And yes, it is voltage across terminal 1. So then this is our diode reference, right? So we have we have a certain forward threshold voltage that we need to cross in order for the diode to start, conducting. I think that's for silicon-based diodes, that's around 0.7 volts. So it should be around this point. And after that point, it just starts conducting. So this is the forward bias region of our diode. So this is the characteristics of our diode simulated using our PSpice software. Okay, so for each device that we have analyzed today, we have seen the characteristics of the 3 devices, right? We have seen the characteristics of our SCR, of our triac, and of our diode. So I explained the SCR output in detail. So for your lab report, what you have to do is you have to simulate all 3 of these and take a screenshot of all the outputs. Okay, so make sure you take a screenshot of those. So take a screenshot of this window, the schematic output window, and attach that with your lab report, so that we see that you're successfully able to simulate this. Same for the triac. So simulate that and then give a snapshot of your output, and the same for the diode. Okay. And you also have some assignments at the end that you have to submit. So we will create an assignment in Google Classroom, and you can finish these assignments in piece by schematics and then upload them in the due time. So that is all for lab 1. We can discuss any issues that you may have in your lab class at your scheduled time. And I hope you understood everything, and I think it was pretty simple in today's lab. So see you in the discussion class, and thank you.